All right, for number 20, if you see that note up there that I have written, it says hint, number of times that your graph changes directions is the same as your degree. So if you're asked, state the minimum degree of each, ignore the part where it says match the graphs to the appropriate function. You don't need to know that. You're just wanting to state the degree. I went ahead and did it for all three of these graphs just so you can get practice. But if you notice, let me make this bigger. Okay, I labeled the graphs 1, 2, 3, 4, 5 for 1 because the degree is 5. So let me explain what I mean by if it changes directions. Okay, so you start at the top here. I'm going down, that's 1. I'm changing directions to up, 2. Changing directions down, 3. Changing directions up, 4. Changing directions down, 5. So that is an easy way to identify your degree. Down, up, down, up, down. Change directions 5 times. So if you look at the graph in the middle, graph 2, up 1, down 2, up 3, down 4. So the degree is 4. The third graph, up 1, down 2, up 3. So the degree is 3. Everybody should get this correct. That is not difficult. Okay, so you're going to be given a graph and you're going to be asked, what is the degree? So identify how many times are you going up and down and changing directions. That is the degree. All right, we're going to skip 21. Nothing on your exam is remotely related to number 21. Number 22, use the graph to identify the polynomial function as even, odd, or neither. So remember that for a graph to be even, like this graph here, even means symmetrical across the y-axis. That means if I split, I'll zoom in here. If I split this graph right down the middle of the y-axis, does the left side look like the right side? Yes. So that graph is even. That's what even means, symmetrical. Odd means that you can rotate 180 degrees. So if any point is in the first quadrant, it's going to rotate and match the point in the third quadrant. So as you can see here, I put a point here and here. Now your exam graph, it's going to be obviously even, obviously odd, or obviously neither, like here. So we're just going to write those 2 points there so that you know that odd is where you transfer from the first to the third quadrant. Same thing for the graph D. This point in the first quadrant, transfer, and it matches the point in the third quadrant. Now you can also look at the second and fourth. So I didn't do that on here. I should have, but you can say that this point matches this point from the second to the fourth quadrant. So it's going to be obviously even or odd. Now, if you look at a graph like B, if I split right down the middle of the y-axis, does the left look like the right? No, not even close. Do I have 2 points that rotate? Do I have a point here and here? No, not even close. So it's going to be obviously even, odd, or neither. Okay, number 23. I was able to fit the work for part A on this paper. Your GCF is 3x. That is because out of both of these terms, I can divide out, I can factor out a 3, and I can factor out 1x. When I take 3x and factor it out of 3x squared, 3 divided by 3 is understood 1. And then if I have 2 x's and I take 1 away, I'm left with 1. So the first term, when you divide out 3x, becomes 1x. The second term, 15 divided by 3 is 5. And then if I have 1x and I take 1x out, I'm left with no x's. So 15x divided by 3x is just 5. And the bottom, the denominator, you have a quadratic that is a trinomial that is factorable. What 2 numbers multiply to negative 10 and add to 3? 5 and negative 2 multiply to negative 10 and add to 3. So you set up both of your binomials, x plus 5, x minus 2. Your x plus 5s cancel, and you're left with your 3x in your numerator and x minus 2 in your denominator. So your answer is 3x divided by x minus 2. Your question on your exam is extremely similar to this, where you have one expression with a GCF, one expression with a quadratic that you factor, and your answer will look similar to this answer. You just are going to have different numbers, okay? So make sure that you understand the process of this answer. Don't forget that your denominator cannot be 0. That's where this comes into play. So looking at the very last step before you start eliminating, look at your denominator. X cannot be negative 5, or it'll make this part 0. X cannot be 2, or it'll make this part 0, because negative 5 plus 5 is 0. 2 minus 2 is 0. So don't forget about your domain. All right, 23B. I was also able to fit it on this paper. You have a quadratic in your numerator that factors what two numbers multiply to negative 18, add to 3. That's going to be negative 3 and 6. 6 times negative 3 is negative 18. And then negative 3 plus 6 is positive 3. So x minus 3, x plus 6. And then in your denominator, x squared minus 36. What two numbers multiply to negative 36? And this is understood 0x. So what two numbers multiply to negative 36 and add to 0? So that's going to be the same number because you need to add to 0, but opposites, one positive, one negative. Negative 6 and positive 6 multiplies to negative 36 and adds to 0. And then if you look at your binomials in your numerator and your binomials in your denominator, your x plus 6 will cancel with itself in the numerator and the denominator. So you're left with x minus 3 divided by x minus 6. Oh, goodness. As your answer. And then again, look in your denominator. Your denominator cannot be 0. So where did those two numbers come from? X cannot be 6 because it'll make that binomial 0. X cannot be negative 6. It'll make that denominator 0. So you're just setting these denominators equal to 0 and then solving. Number 24. I only want you to do part B, and it said see the answer page. So go down here on number 24. It's pretty lengthy. I did it in the way where we get all, like I showed you 3 methods in the teaching lesson, but I did the method where I move all of my terms with the same denominator to the right. So I subtracted 20 over x squared minus 25. When you do that, you get 1 minus 2 divided by x minus 5, what I started with on the right, minus 20 over x squared minus 25. Factor out x squared minus 25. When you factor out x squared minus 25, you get x plus 5 and x minus 5. Okay, because what two numbers multiply negative 25 but add to 0 because you don't have a b value? That's positive 5, negative 5. At that point, you realize that in your first term, you are missing your x plus 5. I have x minus 5, but I'm missing the x plus 5. So I'm going to multiply, my numerator and my denominator by x plus 5. The 2 over x minus 5 times x plus 5 times x plus 5. Then I have a common denominator, x plus 5 times x minus 5. Because I have a common denominator, I can write 2 times x plus 5 minus 20 as my numerator. Okay? And put that numerator all under your denominator, the common denominator, x plus 5, x minus 5. Then, to go to the next step, I distributed the 2x and the 2 times 5 and got the 2x plus 10. That's where I distributed. And then minus 20. Then I added my like terms, 10 and negative 20. 10 and negative 20 gives you the negative 10. So now I have 2x minus 10. Then I factored out my GCF of 2 from 2x minus 10. When I factored out my GCF of 2 from 2x minus 10, that gave me x minus 5. Once you got your x minus 5, you notice that you could cancel your 2x minus 5s, and you're left with 2 over x plus 5. Multiply both sides by the denominator. Will cancel out your denominator and leave you with your numerator 2. On the right side, x plus 5 times 1 is just x plus 5. And then you subtract your 5 from both sides, and you get negative 3. Going back at the part before you start eliminating things, which is actually this step right here, before you start eliminating out of your denominator, because at this step is where we eliminated the x minus 5. This is the part where you look back to see what your domain is. Your domain is all numbers, but x cannot be positive 5, because if x was positive 5, you would have a 0 as a denominator here. And negative 5, you'd have a 0 as a denominator here. So x cannot be positive 5 or negative 5. Does that affect my answer? No, because my answer is negative 3. Okay, I highly recommend practicing that problem over and over and over again and understanding it completely from start to finish. Number 25. There are 46 people entered in a contest. After each round of the contest, 3 people are eliminated. Write an explicit definition for this sequence. The explicit definition is AN equals A sub 1 plus D times N minus 1. Okay, that is your explicit definition. You are going to replace your first term into the A1 spot, your common difference into the D spot. The N minus 1 is standard. It never changes. So where did that 46 come from? Right here. I'm starting with 46 people. What does the first round of the contest have? 46 people. Where did that negative 3 come from? From this statement right here. 3 people are eliminated. Eliminated means that you get smaller. So your common difference is going to be subtract. Okay, if you had something like it grows or it gets bigger or you're adding to, etc., then your D value is going to be positive. But in this case, I'm subtracting because it says eliminated means getting smaller. Okay. So your first term, I'm starting with 46 people, plus your D, minus 3, because I'm getting smaller, times N minus 1. So your exam question is going to be similar to that. It's going to give you the number of whatever you're starting with. That's going to be your first term. And then it's going to tell you if you're getting smaller or getting bigger. That's going to determine if you're adding or subtracting. And then it'll tell you what you're getting smaller or bigger by. And the last one, number 28, use Desmos. So this is talking about a little league coach that uses a baseball throwing machine to help train his players to catch high pop-ups. The machine throws the baseball straight up with an initial velocity of 48 feet per second from a height of 3.5 feet. The function, and it gives you this function right here, models the height in feet of the baseball after seconds that it's thrown. So we're going to use that model. Okay, so go to Desmos. Now, if you look in that function that's given to you, you see H of T and T. You cannot type in any variable other than X into Desmos. So I'm going to type in negative 16x squared plus 48x plus 3.5. And here's my graph that represents the baseball being thrown. So it says that it's being thrown from a height of 3.5. So if you click and hover over this graph, you'll see that the y-intercept is 3.5. Well, that means that the ball is at 0 seconds, because our y value represents seconds, our x value represents seconds, our y value represents height. So at 0 seconds, the ball is 3.5 above. Well, that's because you're entering the ball into a pitching machine of some sort. So the ball is not starting at the ground. It's starting 3.5 feet above the ground, being entered into the pitching machine. Okay. Let's see. So that's where I discussed the y-intercept, 0, 3.5. The ball is being thrown from 3.5 feet at 0 seconds. It's 3.5 feet above the ground. Let's talk about the vertex. Remember, the vertex is this height point right here. In this case, it's 1.5 and 39.5. So the vertex tells me that the max height is going to be 39.5, because remember, the y value represents the height. So the height is going to be 39.5, what is it, feet? 39.5 feet at 1.5 seconds. So 1.5 seconds after the ball is entered into the pitching machine, the ball will reach 39.5 feet. Then it's going to start to decrease in height as it goes down. So as the time increases, the height decreases because it's falling at that point. So calculate the number of seconds it would take the baseball to reach its maximum height. And what is the maximum height reached by the baseball? You don't have to calculate. Just look at your vertex and understand which value represents what. 1.5 seconds, 39.5 feet. Part C, if the player fails to catch the baseball, how many seconds will it take for the baseball to hit the ground? Round to the nearest decimal. So remember, X values represents the time, Y value represents the height. So at 0 seconds, the ball is 3.5, and then at 1.5 seconds, it's 39.5, and then it starts to fall, and this X-intercept is going to represent when it hits the ground. It's at 0 feet at 3.071 seconds. So this is answered as 3.071 seconds because the X-intercept is 3.071, 0. And it specifically told you to round to 3 decimal places. Okay, so that covers all your study guide. If you look on the very last page of the notes, I put 2 extra problems because there's 2 problems on your study guide or on your exam that's not covered on your study guide. And they're pretty simple. So if you take the square root of negative 32, 32 is not a perfect root. So you're going to have to split 32 into 2 numbers that multiply to each other that is a perfect root. 16 is a perfect root. If you don't know your perfect roots, please learn them. Okay, your perfect roots are 1 because it's 1. What's 2 squared? 4. What's 3 squared? 9. What's 4 squared? 16. What's 5 squared? 25. Okay, so those are your perfect roots through 5, and you can keep going. 6, 36, 7, 49, etc., etc. So the perfect root that is a multiple of 32 is 16 times 2, because 16 times 2 is 32, and 16 is a perfect root. Now I'm going to take the root of negative 16. I'm going to pull out this negative, and negative under a root is replaced with I. And then the root of 16 is 4. So that's where that 4i comes from, taking the root of negative 16. And then you're going to leave the root of 2 as the root of 2 in your answer. And the last question, you're going to be met with a question like this, where you just simply solve for x. Subtract 20 from both sides. You're left with 2x squared equals negative 20. Divide out your 2. You're left with negative 10. They just want to make sure you understand that a negative under a square root, because you're going to take the square root of both sides to eliminate your x. To eliminate and get x by itself, when you have x squared, you take the square root. So when you take the square root of a negative, all you need to know is that you're going to replace the negative with I. And the root of 10, there's no multiples of 10 that's a perfect root. The only multiples of 10 is 5 and 2 and 10 and 1. 5 and 2 and 10 and 1, neither one of those are perfect roots. So it's just going to be I root of 10. And your answer on your, or your question on your exam is going to be exactly like this, just with different numbers. Maybe instead of a 2 here, you'll have a 3. Maybe instead of a 20 here, you might have a 30, etc., etc. Okay, just understand you're going to do the same process, just with different numbers.